Welcome back to the channel. So today we are going to discuss this sort color problem. It is a lead code 75 and it is a medium category problem, and this you can expect in any of the data related interview, be it data engineer, data analyst, or data science. So any of the data roles, you can expect this problem, right? So let's understand the problem statement. So given an array nums, so we have been given this nums array with an object colored red, white, blue. So basically we have three kind of object, 0, 1 and 2. So basically 0 represent red, 1 represent white and 2 represent blue. We need to sort them in place, right? So that the object of the same color are adjacent with the colors in the order red, white, and blue. So it's like we need to sort them in ascending order where we should put zeros at the beginning and then 1 and then 2, where 0 represent the red color, 1 represent white color, and 2 represent blue color. So I hope the problem statement is clear. It shows that we need to sort this array. But we have been given this condition that we cannot use any inbuilt function like sort, right? So that it would have been very easy problem, right? We could have write a dot sort, like array dot sort, and this will do the job for us. But this is not allowed, and this solution we cannot give in an interview, right? That's why the problem is of medium category, right? So let's try to understand basically this problem by doing the dry run, and let's see the brute force and then the optimized approach to solve this problem, right? So this is basically the input and output. Okay, so let's understand. Let me write the array once again. Okay, so in the array we have been given 2 0 2 1 1 0, right? And in the output we have first 0 and then 1 and then 2. So 0 is basically red color, this is white color, and this is blue color, I think, right? So how we can approach this problem? So if you see here, we only have three possible values, or three possible color or object, right? So what we can do in a brute force basically, so if you see here, like this is not a brute force, you can see that you can say it is also a optimal approach, but it's like we will need to do this in the multiple pass. But if you see here, the follow-up is, could you come up with the solution with a one pass algorithm using only constant extra space? So basically the solution which I am going to give first, this the first solution would be where we will use the multiple pass. Multiple pass means like we will be running the for loop for the multiple time. But the second solution would be only one single or a single for loop we will solve this problem. So first we will discuss this, and second we will discuss this. Okay, so to approach this problem, I think it is simple. Since we have only three objects, so what we can have, we can have three variable: count 0, count 1, count 2. So what we will do, we will run a for loop on this, and we will count how many like zeros are there, how many ones are there, how many twos are there. And once we know the values, then we can definitely override these value with the respective count, right? So if I have to do this one, how I will do, so I need to count the number of zeros. So what I will do, basically the code would look like this. So for I in okay, in a, right? So I will write like this: if I equal to 0, then what I will do, I will increase the count 0 plus plus, right? Elif if I equal to 1, then what I will do, count 1 plus plus. Similarly, else count 2 plus plus. This will give us the count of all the element. So if you see here, the count of 0 is what, 2. Similarly, here the count of 1 is basically 2, right? These two values, and then zeros are these. And count of 2 is what, 2, right? So each and every element is occurring 2 times. So once we have the count, then the next step, what we can do? Next step, what we can do is we can have a loop again. So for I in range, and this we can run it length of a, right? here we are saying the the array is basically a, and what we can do, we can simply override the value. So here the count, okay, so instead of using this approach, what we can do, we can have three for loop, three for loop, right? Three for loop, and we can simply run the first for loop for the two time, second for loop for the two time, third for loop for the two time, and override the values, right? Override the values, override the array. So that would be the in place algorithm. Like in place algorithm, we are not using any extra space and we are solving this problem in place. But only the problem over here is we are using the multiple paths to solve this problem, right? This is also optimal approach, but not in terms of like the passes, right? The number of time we are running this loops and all, right? So if we talk about the time complexity and space complexity, so what is would be the time complexity? We are simply running the for loop for the multiple time, and at max what we will do, we will run the for loop for the array of a, right? So that would be the of complexity of o of 1, o of n basically, and space complexity obviously it would be o of 1. Why? Because we are simply using few variables, right? So let me bring the code over here and try to dry run it so that it would be very easy for us to understand. So this is the basically the brute force approach which I'm saying, right? Because here we are using the multiple passes to solve this problem. So let me paste over here. Okay, let me adjust this properly. Okay, okay. So this is the solution basically, and let me take the array and do the dry run. So array was 2021110, 2021110, right? 0, 1, 2, 3, 4, 5. So these are the indexes basically. Okay, let me reduce the size. Okay, okay. So now if we see the code, so this is basically the length of the array. So here the length is basically 5, sorry 6, and the count. So this we understood, right? So this piece of code will bring us the count for us, right? So what we are doing, we are running through the this array, and we are saying if the value is 0, then increase the count of 0. Similarly, count of 1, count of 2. So the each value would be count 0 would be 2, count 1 would be 2, count 2 would be 2. So this we know, right? This we understood, and this is the piece of code for the same. The next thing is putting this value in place, right? Putting this value. So let me copy this again over here below. Okay, let me write it again. So array is 2021110. Okay, so what we are doing over here, so we are saying for I in range count of 0. So count of 0 is 2. That means it will run for 2 times 0 comma 1. And here we have the helper pointer. So helper is initially over here. So this is basically the helper. Helper equal to 0. So what we are saying, a of helper. So basically here we are saying put 0. So this value will change to 0 and will increase the helper pointer. So helper would come over here, right? And then again this loop will run because the value is 2. So it will run for 2 times 0 comma 1. So again here we would put 0 and will increase the helper pointer. So now once the loop ends, the helper would be at the index from where the next run will start, right? So helper will increase and it would be 2. Initially it was 0, and then it become 1 for the second run, and now helper would be 2, and this will exhaust, right? Because this loop will run only 2 times, right? So now helper is here, and then again this loop will run. How many times it will run? It will run for 2 times only, right? So again we will put a of helper. So this pointer, this will be 1, and then we'll increase the helper. So helper will come over here, and then again this will run because we will run only for 2 time, right? So again here we will 1, 1 would be there, and then we'll increase the helper. So helper will come over here, and now again it will check if I is less than range. No, it is not less than range, because this will run only for 2 time, and we have already ran for the 2 time. So I will be here, and then now again this loop will run, right? So we will put 2 over here at the helper pointer, and again helper will increase, and we'll put 2 again over here. And then now, since we have already exhausted 2 time, and like we don't have any other extra run, right? So after the execution, we will have the values like 0 0 1 1 2 2, and this is what we need. So yes, I think you understood this approach. Here basically we are using the multiple passes. So if you count the passes, basically, so here we are doing okay. So here we are running one pass, then here we are running second pass, third pass, and then below fourth pass. So we are solving this problem via four passes, right? So, but in the follow-up, we have been given this, can we solve this problem in only one pass? So how to approach that? So let me explain you. So let me write the array using this. So 2 0 2 1 1 0. So this is the array, right? As we know that at max we have three distinct value, right? Can we use three pointers? Can we use three pointers? So in our previous videos also, I have told you that if you find such situation like this, we know, right? In DSA we have problems like three sum problem, four sum problem, two sum problem, and then two pointer approach. So these kind of problem is what? These are nothing but the two. There is something called something is there for two time, three time, or we can find 2 points. So all these are the similar kind of problem which we solve, right, using the pointers approach. So here also, if you see, we have total altogether we have three distinct value, right? So can we have three different variables? Yes, we can have. We can have one variable for 0, we can have one variable for 1, we can have one variable for 2, right? So like this we understood. Now the next second step is, we know that 0 will always be at the beginning, and then once 0 is done, then we will have ones. Once the 1 is done, then we will have twos, right? So can we have 0 pointer over here? Like we can have low pointer, we can call it as low, and then once again we can have a high pointer, right? Right, this you understood. So now once the zeros are settled, one and twos are settled, one will automatically settle by at his position, right? So what we can do, we can use the low high, and we can have a mid pointer. So mid pointer will help us placing the one automatically, right? We will try to place zeros and twos at their respective places. In that process, one will automatically be there at his position, right? So this is the algorithm basically. So let me bring the code and help you understood the algorithm, right? So this is the optimal approach, basically the one pass algorithm. So let me copy this and paste over here. Okay, and let me show you the code. Okay, so before showing the code, let me write the array again. So we'll have 2 0 2 1 1 0, right? So this is the array. Okay, so what we are doing, we are saying low at 0. So here we have low, here we have high, right? N is basically 6, N is 6, and we have the pointer over here 0 1 2 3 4 5. Okay, so what we are saying, till the point mid is less than high. So basically mid is starting from here. As I mentioned, like the mid is the pointer which will help us sorting the array, right? Then what we are saying, so this is the first block, this is the second block, and this is the third block. Let's understand one by one. So what we are saying, a of mid is 0. So a of mid, is this equal to 0? No, it is not equal to 0. So now the second block will execute. If it is 1, no. If it is 2, yes, it is 2. Then what we are doing, we are simply swapping the values. Swap, what we are doing, swapping the high value with mid value, right? High value with mid value, and we are decreasing the high pointer. So what exactly we are saying, we are saying swap these two values. Why? Because this value is why swapping with this, because we want the two to be at the end of the array, and end is what, highlighting the high pointer. So we are swapping these two values. So like how the values would look like, so here we would be having 2, here would be 0, and here we will 2. And now since this high pointer is settled, now like basically we want 2 at the end of the array, and that is what exactly we found. So we'll decrease this high pointer, right? High pointer, we are not increasing the mid pointer, right? If you see here, we are not increasing the mid pointer, like mid pointer over here. Why? Because let's say like we don't know what exactly is here at the mid pointer, right? Like what was here, like the possible values are what, 0 comma 1, right? And we have swapped the values, so that's why we cannot increase or increase the value of mid over here, right? Because let's say if this value would have 1, then that would make the value or calculation wrong, right? So we cannot increase the mid pointer over here. So I hope you understood this point. Now again this will run, and now again mid is less than high, yes, then this value will be checked and swap will happen. So again, since both the value are at the same place, so we'll increase both the value, like the swapping will done and 0 will be swapped with 0. So we will have the same value at both the places. So here we will have low and high, right? Since 0, like whatever we want at the low place, that we have already placed, so we'll increase the low and sorry, instead of low this would be mid. Okay, so again this will happen since both the values are same. Again this will uh, 0 will be swapped with 0, and will come over here, low and mid. So again, like since a of mid is 2, so this will be swapped with high. So what will happen here, uh, this value would become 1 and this value become 2, right? And high will decrease by 1, so high would come over here, high would come over here, right? So again, this will check if mid is equal to 1. Yes, mid will increase, right? Because it is at the correct place. So mid will be here, right? Again, mid is less than equal to high. Yes, they both are at the same point. So mid is equal to 1. Yes, then mid will increase. So mid will come over here, mid, right? So now everything is at its place. The array is already sorted, 0 0 1 1 2 2, and this mid is more than high. If you see here, mid should be less than high. So we are out of this array or out of this loop, and like the array is also sorted in place, right? So this is basically the one pass algorithm. And if we talk about the time complexity and space complexity, so time complexity is basically O of n, right? We are iterating the entire array exactly once, and the space complexity is just a few variables, so it is O of 1, right? So yes, I think you understood this problem. So if you like this content, please do like, subscribe, share the channel. So let's meet in the next problem. Until then, bye.